All right, welcome to our first lightning talk of UGM 2021. This is Brett Hartley from Sanger. I'm going to read all these words. Log centralization with rsyslog and the elasticstack, and how Sanger use it to identify issues before they are reported. Go for it.
All right, thanks, Terrell. So yeah, we at Sanger, we have log centralization, and Raj's talk on Tuesday kind of implied that it was a thing that maybe iRods should look at, but it's perfectly possible to do outside of iRods. So I'm just going to cover how we do it and why I think is important, and some things that it's done for us. So first, I'll just go over the configuration and how we do it before actually going into why we do it. So all of the iRods logs are close enough to syslog that if you just feed them into rsyslog, it will send them away. So it sends them away to logstash, and then from there, logstash puts them into an Elasticsearch index, and we can view them in Kibana. So this is the logstash configuration. When iRods logs actually go into syslog, then all you need is that first line, but until then, you need the module that picks up from the logs. This one just picks up rods logs, but we do also pick up RE logs and server logs as well, because it's just the same, it just didn't fit on the slide. This is the logstash configuration, so it listens on port 10,514 because the standard is 514, and that's too low because 1024. Then we filter it and separate out all the potential information that could be available. So timestamp, where it came from, what program, if there's a PID, we want the PID. Then also some things will provide another timestamp and another PID and a log level, and then the actual message. And then we add a couple more fields just because we can. And then feed all of that into Elasticsearch, which has a really, really simple template because we do it all with dynamic templates and just kind of go, yeah, whatever you think is right, it'll be fine. And so why do we do this is kind of a more important question than how, because there's plenty of solutions out there to do it. So first thing, it's useful to pick out trends to try and identify when things aren't acting as they should do, as they normally do. So this is a heat map that we have for our, well, I suppose all of our iRods machines, but also all of our other machines. This is just filtered to just iRods. So generally, you just kind of, there's too many logs to look at, right? This scale goes up to, well, 10,000 is the dark color on the two providers on the left there, and yeah, there's easily hundreds of thousands of logs in there. So we can't read them all. So this kind of helps us pick up what we're supposed to be looking at. And so looking at this, we have three kind of obvious trends that we would always expect to be true, which is that the indexing machine has a bunch of errors in the relog because it's indexing a bunch of things that it's already indexed, and gives an error message every time it does, which is fine, but maybe we should turn it off. Then you'd expect that the two providers in the large zone have more error logs than anything else, because any errors that occur pretty much always appear in both the consumer log and in the provider log. So the providers have more errors. And the third thing is that those providers also don't have anything in the relog, because you're only supposed to have one RE server running per zone, so they shouldn't have it running, so they shouldn't be logging anything for it. From that narrows out the three most obvious things in here. The next most obvious is that iRod Seek IO3 has a bunch of error messages today. So we look at, well, why does it have a bunch of error messages today? It's kind of understandable, because it's the oldest machine that still has write space in the largest zone, and it's due for retirement this year, and it's kind of, but yeah, it's it's getting old and needs replacing. So it makes sense that it's making some complaining noises. But obviously, I've not actually looked at it properly because this is from a couple hours ago. So I would have to go and have a look at why. But you can clearly see how this would end up giving you a way to find out what it is that you're supposed to be looking at, because it's not normal. So then we have the a couple of actual use cases where we've identified a problem, looked at it and gone, well, this is a thing, this is how we could fix it. So this is a graph of NX domain errors in iRods, which is when you make a DNS query and the domain just doesn't exist. So all of our iRods infrastructure had a domain in the search order that didn't exist. So we get a bunch of these errors. We didn't notice this until we compared the number of NX domain errors in iRods to the number of NX domain errors in everything else. And you can see there is an enormous difference when we removed that domain from the search order. There is no prize for guessing when we did it. It's just such a massive drop. The other example is so file mismatches, right? Size and checksum. There's not really an easy way to prevent users from ever seeing mismatches in checksum or mismatches in size, because it just happens, right? Your file change, just any sort of minor change can make that happen, and they're bound to happen at the sort of scale that we're working at. So the problem becomes not preventing them from happening, but finding out when they happen, because the user might not tell us. Like, they'll just see the issue and go, all right, I'll try something else. There might be a copy somewhere else in the institute, or they might just specify the other replica. There's plenty of ways around it. So this is the table of all the things that come out of both ifsec and people running stuff. I've filtered it to just my things, because I have a bunch of files that are intentionally wrong to prove that the scripts to generate them work. So this is a table of all of the files that have size mismatches and checksum mismatches. It's a little bit more complicated than the other example, because we do actually have to parse all of the lines and separate out, well, which bit is the file path and which bit is the mismatch type, and what's the object path as well, because they're all different and they're all useful information. And then at the bottom here, I have this. This is an actual error message produced by, I think that's an ifsec one, saying, well, look, this is a checksum mismatch on this file. This is the checksum it has, and this is the checksum it's supposed to have. Which that latter checksum, some people might recognize as being the checksum of a zero-length file, which that file is not. So yeah, I mean, we get benefit from it by being able to see what it is that's going on and being able to see when that changes. And we also get the ability to look into what is different between our iRods installs and all the other installs. And then also we get the chance to see kind of almost audits, but obviously we don't have the audit plugin yet. And we are hopefully looking at that in the future, which would add to this file mismatches thing. And it gives us the ability to kind of better observe what's going on, and therefore better react to changes and to errors, and almost do it before the users noticed in a lot of cases, which is really powerful. And
very good. We are at the time. Anybody have a question for Brett? Lightning talk number 1. Very good, sir. Thank you.